Yeah, think I will slowly start. So, hello everybody. Welcome to this talk, an early look at Windows Container. My name is Mikkel Chatillon. I'm a technical evangelist at Microsoft Switzerland. As my last name suggests, I come from the French part. That's why I'm having this talk in English. My German is noch nicht so gut. So, the talk is an early look at Windows Container. You can already try so containers is a new virtualization technology that comes from the Linux world. We're currently working into implementing it in the next version of Windows Server. So you can already try everything that I'm going to show you today by downloading the next version. So the technical preview for was the one I will be using today. Today is a level 100 talk. That means that I'm assuming that any of you have any knowledge on container, Docker, or whatsoever. So I will take everything from the start. So if you're already a container guru, maybe that's not the right talk for you. Sorry, but I will be happy to talk with you after this session. So, what's the plan for today? My agenda is the following. As I told you, I will start on what are containers, so explaining you the basic principle behind this technology, why it's so interesting, then how can you build your own container image, and finally, what containers are actually bringing to the development cycle, so to DevOps. So, let me start right away. So what are containers? And I would like to start with a story. I am a big fan of TV shows in general, and right now I am watching a TV show that is Black Sails. It's about piracy. I love pirates. And well, I was surprised by something. Is the pirates and merchant at this time were carrying a lot of different goods. So, for example, here you have a sack of I don't know what, or here barrel, probably rum, but all these merchandises came in different shapes. And actually, I did a lot of research because I love history. And it turns out that this was a mess to handle for the people at that time. Because the goods were in different shapes, in different sizes. That means that if you think about the ships carrying rum or the ship carrying sugar had to be designed in a different way. Then into the harbor, you had to have different infrastructure depending on what kind of merchandise you had to have. Then, of course, there was also the problem that you cannot put two different merchandise in the same boat. For example, turns out you cannot transport coffee and beans in the same cargo, because then one spoils another. I don't know why, I'm not a specialist on this, but it turns out that's what they do. And so it was really, really complex. So there was really a huge logistics chain in place. And then a guy in the 70s had a brilliant idea. Let's introduce what we call a container. So yeah, now I think you understand why I'm telling you this story. So the idea behind this container is basically everybody know, I think, what a container is. A container is a box, okay? It's a big box. I think it ships in 3 different sizes, and everybody knows this standard, okay? So when now we are expecting some merchandises in a harbor or anywhere, we're expecting it to come inside a container. So everything along the supply chain is optimized to receive those containers. This led into tremendous savings in all the logistic chain. So it solved basically all the problems that I told you before. Well, I'm telling you this story because if we think about our current IT landscape, we're having different technology stacks. Sometimes, different technology stacks, sometimes they don't live well with each other on the same machine. Sometimes even different versions of the same technology don't work well in the same machine. You are having different environment, Windows, Linux, different versions, and then mostly you have to manage all this. You have to manage updates. You have to manage all this infrastructure. So I'm not saying that we're living in a pirate world, but yeah, we can have something. So we have already some kind of way of dealing with this problem, okay? And it's called virtual machines. So virtual machines are around since 15 years. I think every one of you should be quite comfortable with them. Just a little reminder, you are having the physical server, so we always need this bare metal. Then we'll have this hypervisor, which will ensure that the isolation between the different virtual machines. A virtual machine consists of a guest, so you're having a copy of the guest operating system, and then you can put whatever you want on top of it, okay? So here you're having isolation, which is guaranteed by the hypervisor. But the talk of today is not about virtual machine, it's about container. So let's compare the virtual machine with the container. So here on the left, you're having a container. We can immediately see a few differences. We don't need an hypervisor, okay? What we need is a operating system that has container support. For example, the next version of Windows Server. We also have some Linux distribution that offer container support. And then, directly sitting on top of this OS, you will have the container, okay? And basically, the container, you don't have any guest OS. What you have is your app, you have the libraries, so the app's dependencies, that's it. So immediately, you can see here one of the benefits of the containers. It's the size. It's much more lightweight. Let's go a bit more in details. So as I told you, a container is basically a bundle of everything your app needs to run, okay? So a container will encompass everything, the environment that your app needs. The virtualization is going to be done by the operating system. I'm going to show you a bit later, but we are using some techniques to ensure virtualizations among the container. The operating system will be shared. That means that there is some kind of legend that a lot of people tell me about, like they tell me always, hey, containers are great, because that means that Linux containers will be able to run on Windows. Sorry, this is not true, okay? You will always need the kernel, so the containers will call the kernel of the operating system. That means that Windows containers will run on a Windows machine, and Linux containers will run on the Linux machine, okay? And then, well, you're having this flexible, fast approach. Basically, they're really small. You will see that you can start a container like this. They're really, really small, and the development. Containers are nowadays really used mostly for development and testing because you can just start them really, really rapidly. And yeah, so you can run your test and try out some new stuff in a new environment really, really quickly. So let me explain you a bit how a container is built. Basically, a container is a succession of image layers, okay? So as I love food, I try to compare a container with something that I love, pizza, okay? So basically, when you think about a pizza margherita, it's just a succession of different layers. So, well, I did not take an actual picture of pizza because I did not want it to make you hungry. But yeah, the base layer, this is going to be, yeah, base layer. So for pizza, it's going to be the bread. And then we add something, it's going to be the tomato sauce, and then the mozzarella. So if we think about a container app, I will have here on the last layer my app, okay, which is, in that case here, a static app, so HTML files. This app will need IIS, okay? It will need my web server to run. And my web server, what it's going to do is going to need Windows Server Core, so Windows Server, in order to run, okay? So a bit of nomenclature here. Those layers here, I call the image layer, okay? So those image layers are completely read-only. Okay, you cannot change this images layer. This is not possible. Everything you are going to do inside a running container, it's going to be done inside the last layer, which is called the sandbox, or the container runtime. I will explain you a bit more later how exactly does this relate, but this is the idea. The idea is really the images are untouchable. They will always remain the same. And this is great. You know why? That's because then you can build on top of this. For example, let's say that I want to make my app a bit more dynamic. So what I'm going to do is I'm going to add a layer. So on my pizza, I want now a prosciutto. So here's prosciutto. Yeah, I've done it myself. I'm quite proud of it. And so here, what it will translate is I will just load a new from the repository. So there is repositories that exist, public ones or private ones. I will just load an image with node installed. And then, as before, the last layer is going to be the runtime, okay, the sandbox, where actually I will do my modification. And then that means that if you want to change technology, you can change the node layer, okay? You can put something else. So how does a container work? If you were paying attention, I told you before that there is no copy of the operating system in the container. But on my previous slide, there was Windows as the base layer, Windows Server Core. So now you might be asking yourself, hey, what is it telling about? Is this a lie, or how does it work? Well, the containers, as we're implementing them, so we're implementing them in partnership with Docker. The idea is, on Docker container, we're using a technology called copy and write. That means that we will use the same vision on an image that's common amongst container, okay? So let's say that those two containers, here dark blue and light blue, both of them will need the Windows Server Core image. So basically, the dark blue container will have this vision, okay? He will have the vision on the files. Well, the light blue container is going to have exactly the same vision on the same files. We're not duplicating the files. They're just going to see the same files. That's why the image layer are always untouchable. They're completely read-only. Every modification, because of course you want sometimes to do a change. If you change those files, basically here the light blue container will change some files in the operating system. These modifications are going to be carried inside the last level. You remember the sandbox. So it won't affect the other containers running on the system. And then, as I told you, a container is a succession of image layers. That means that, for example, if those two containers are sharing this, are both using IIS, basically those both containers will share the same file. So you will only have IIS installed one time, okay? And both of them will share the same install. Another thing is the isolation. We are using technologies inside the operating system that allows process isolation, namespace isolation, network isolation in a way that from the dark blue container, it thinks he only sees his own process, his own networking stack, everything, and the same from the other side. One way you could think about it is a virtual machine is basically a way to make an operating system believe that he's sitting alone on a physical machine, okay? A container is a way of making an application believe that she is sitting alone on an operating system. So this app thinks she is alone on the operating system, but there are others. And then the last aspect that is really, really important if you go to the cloud or in clusters is the resource governance. Containers are good citizens, so that means that you can restrict them access to tell them, hey, I only want you to use one CPU, or I only want you to use this kind of memory percentage, this much, this access. And you can set that really, really easily, okay? So yeah, I think I talked a lot, so now it's time to show you a bit how containers look like. So all my demos will be run through the command line. If you don't like the command line, I'm really sorry for you. So my first demo, I'm going to show you the Docker command line, okay? So here, well, I'm sitting on a standard Windows Server vNext machine, so it's the technical preview for, I told you, and I have this Docker, which is here, okay? So Docker, it's actually allowing me to manage these containers. So if I do Docker images, you can see that here I already have a few images that are installed on this machine. For example, here I have Windows Server Core or Nano Server, and I have a few others that I will use later. So for example, Microsoft ASP.NET. So what I want to do with you now is to create a container. So let's say that I want to program a .NET app, okay? I have nothing. So if I use the NVM, so .NET Version Manager, don't have it. .NET Execution, don't have it either. There is nothing here for me. You can see, however, that I'm having this Microsoft/ASP.NET image that I loaded from the public Docker hub, where actually Microsoft published this image. So if I do docker run, that's the command to start a container, I tell him, hey, I want to be interactive with this container. And then I'm going to tell him, hey, I need this one, so Microsoft ASP.NET, and now I want the command line with this container. So here we go. So now I started the container. Okay, so what happened in these few seconds is we started a completely new Windows machine. We installed .NET on it, and yeah, here I am. So here now, if I do dnvm, you can see that I'm going to have the .NET version manager. If I do dnx, oh yeah, sorry, I have to. Yeah. Yes, and if I do dnx, I also have dnx here. So now I'm having a machine, .NET ready to use. I can do whatever I want. Okay? So did you ever seen Windows booting that fast? Frankly? Okay. So if I go to the base, to the root, you can see that, as you would expect, I have everything. So full Windows view with the techniques I explained you before. So now I just want to show you what I mean by isolation, okay? So I thought let's delete some file, but I don't think it's aggressive enough. So let's do something a bit more fun. So reg delete hklm/software. Yeah. Okay. So here I am going to change the registry and delete basically the software key. Okay, so let's put this on the side. So on the left, I'm going to have my container. On the right, I'm going to have my Windows normal system. Okay. So here you can see that this time if I check what are the running container, actually, well, you can see this. So, sorry. Yeah, you can see that I'm having this container that started a minute ago with the Microsoft ASP.NET image, and the name is Amazing Hodgkin. I have no idea what the Hodgkin is, but if you don't give a name to your container, Docker will give names for you. So, and they're usually quite funny, so don't give names. Well, so here, sorry, on my left container, now I broke some stuff. So if I use cmd, my system cannot execute the specified program, okay, because it doesn't know what it is. So I need some help. Well, there is no help either. If I go here on my base system, well, if I do cmd, no problem, help, no problem, everything is working, okay? Because what I did is I deleted this registry key on my sandbox, not on my base image layer, okay? So, yeah, think work. Okay, so that was for my base demonstration. Now, I want to show you, sorry, the other way to interact with Docker containers. And of course, we're building also a PowerShell experience. So if you're using PowerShell, I hope you're happy. Get container image. And here you can see with the PowerShell, I'm getting also those two images. I have Nano Server and Windows Server Core. Okay. I will also here start. Yeah, sorry, it's I'm a bit less used to PowerShell, so that's why I'm copying it. So here, the image is a bit, the command is a bit similar. So I'm creating a new container using the Windows Server Core image. I'm giving it the name here. And, well, I'm giving it a switch name, so it's a vSwitch to get to the internet. So now I'm creating this image. Yeah, sorry. So you can see it returns me a PowerShell object. So if you're used to PowerShell, of course, you can use all the PowerShell goodness that you want. So get container, and I'm going to pipe the result and start container. And now it's starting my container, okay? So if you want to enter in a remote session with a PowerShell container, you can use enter PS session and the container name. Sorry, container name. And the container name is first demo. Okay, that's fine. And here I'm going to have, so you can see here the command line changed a bit, so now I know that I'm in my container first demo. I want to show you something now, because there is isolation, but let's see a bit the limits of it. If I do now get process, oh, it freezes for some reasons. Okay, cool. Yeah. So if I do the get process, here you can see that you're having this CRSS process, okay? This CRSS process is a base Windows Server process. Yeah, you don't have to memorize it, it's 1532, but I will show it later. If I exit the container now I am back to my base machine, okay? So here, I will just get all the process, and I will pipe it to just find the one with CSRSS, because of course, on my base machine, I have much more processes than that. So you can see here, I have several ones, because actually I have several containers running and other stuff as well. Here, 1532. So from the base operating system, I'm able to see the process of the container. However, inside the container, I was not able to see any of the other processes running on these machines, okay? So that's what I meant before with the processes isolation. And it's the same for the disk and for all the other stacks on the machine. Well, I also told you that containers are lightweight. So now I want to do something that I think it's fun. Maybe it's not, you will tell me. But what I'm going to do is I'm going to start 10 new Windows instance, okay? So here, basically it's a loop, okay? I'm creating a new container, demo scale with the number of this container, and then I start the container, okay? And let me just here put the task manager. Sorry. So with the performance, memory, okay? So let's go. Okay, so yeah, those are 10 new Windows Server where you could install whatever you want. And well, I don't know if I was starting 10 VMs how it would look like. I think it will be much less fast and it will take a bit more memory. But yeah, here you go. So now I'm having those 10 Windows machines here. Okay, so if I do get container, here you can see that basically I have those 10 machines running. And of course, I can stop them. I will stop them. So it's exactly the same. So loop 10 times, I stop the container, and then I remove it. Yeah, okay, so it's just a line going down. Okay, I know it's not. But I still hope you liked it. Thing is, yeah, now, let me get back to my slides. So, I told you about all this layer system. You can deploy these containers in two different runtime, okay? We are offering you on the bottom here the Windows Server containers, which is what I showed you until now, okay? Those Windows Server container is with the isolation. Those Windows Server container is more or less, it's the same principle than the Linux containers, okay? The technologies are not the same underlying, but the principle are the same. I showed you that from the host we were able to see the processes running inside the container. And sometimes we know that customers want more isolation, okay? In that case, we built the Hyper-V containers, and I'm going to explain them in the next slides. All of that, you can manage them using either PowerShell, either Docker. You can choose, okay? Today, they don't have the same expressivity level, but at the time of the release, they will have, okay? So we really plan, like, you can really choose one or another. If you're using the preview, be just aware that if you create containers using PowerShell, you won't be able to manage them using Docker for now, okay? So you have to choose one. Basically, if you're doing a lot with Windows, you're a really PowerShell expert, I advise you to use PowerShell. If you are more into a hybrid scenario where you have either Windows, either Linux, use Docker, because then you will be able to run the command, and the exact same commands will have the same effect. So if I issue a Docker run command, it will start a container or in Windows or in Linux. Okay. Well, so this is an image of the Windows container. So you can see the container management stack on the left, the kernel, and basically I only have those containers sitting directly on the OS. Okay. For the Hyper-V container, here you will require Hyper-V. We'll require Hyper-V sitting on the host OS. And basically here, we'll do on each container optimized copy of the kernel, and they will be isolated using Hyper-V partitioning, okay? So they will be really, really isolated using technology which is like VM, but still in more lightweight, okay? So here, I just want to show you a Hyper-V container. Sorry. So I can close that. I can put my PowerShell. I will clear that so we have more space. And here, so here I will create a container on Nano server. Okay, so you see a bit other stuff. Here, so you can see I have a demo Hyper-V on Nano server. Now, if I issue this command, I'm just asking for a few features of this container. You can see here the runtime type is default. You see, until now, I did exactly the same thing as I did before. Well, here I am having this set container, and here I can change things about the container that I already have. So here I'm saying to this container, hey, I want you to run into Hyper-V mode. That means that you don't have to design the container 2 times. It's the same container, and then when you deploy them, you can say, hey, this is an environment that I don't trust that much, or I need more isolation here, okay? So basically, here what I'm going to do is, of course, I'm going to start. What was the name of my container? Yeah, start container, sorry. I was a bit distracted. And name demo Hyper-V. It's a bit slower than before because it's a bit more beefy, but I think it's still faster than a VM. And here, what I want to do is I will do as before. So I will the CSRSS, and now let me enter inside my container. Enter PS session minus container name, and I will just put demo Hyper-V. Yes. So I'm entering into the set. Okay, cool, I'm here. So now let me get the processes. And you can see here CSRSS 904. And here on my base machine, I don't see it. The Hyper-V container are really giving you this kind of virtual machine-like isolation, okay? So here we go. So let's go back to my deck. And of course, here you're asking yourself, which one should I choose? It depends. If you want to be more fast, more efficient, use the standard Windows Server container. They're much faster. And then if you want to be more isolated, more secure, then you use the Hyper-V container. Typically, a good case, it's hostile multi-tenant. So if you're having like multiple teams that hate each other, or multiple customers that are hostile toward each other, maybe it's a better example. In that case, we would recommend using Hyper-V containers. Okay, so I'm already running late. So how to build containers? How to build those images? Well, you have 2 ways, okay? So the first way is a manual image creation. That's what I showed before. So you're having your container OS image. So Windows Server, you're having the C Windows view, so the standard view on an operating system. On the sandbox, then you issue this command. Install the Windows feature web server, okay? So it's going to install the IIS here. So it's going basically to add view on new files. It's going to do everything in the sandbox, and then you're happy. But then you want to make this as an image. So you're having this command, which is called docker commit. And basically here, it's going simply to put this image in your repository. Then you can instantiate it. This is good, but you might want more automation, something a bit more clean. So that's why we have the concept of Docker files. A Docker file is like a recipe, okay? When you're building the containers, it will tell exactly how you should build the container. So this is the Docker file that I will be using in the demo I will do in a few minutes. It says from Microsoft ASP.NET. That's the image that is prior to the image I'm trying to build. So basically, Basically, what it will do, it will check the local repository. Docker Engine will say, hey, do we have something called Microsoft ASP.NET? Well, no, we don't have anything. So then it can go to the Docker Hub, or well, to your private repository, if you have one. And then here it will find the Microsoft ASP.NET image. So the Microsoft ASP.NET image also has a Docker file. And this Docker file says, I'm based on Windows Server Core. And then I do other stuff that you probably can't read. I will explain you a bit later, don't worry. And well, here, basically, it will check, hey, do we have Windows Server Core here? Yes, we do. So it will instantiate a Windows Server Core image. Then it will go to the next lines. The next lines, so I'm installing ASP, okay? So basically, what I'm doing is I'm installing dnvm and then dnx. So it will just install everything until I'm reaching a state described by this Docker file. So, yeah, sorry, I keep clicking on the wrong button. So then I will have Microsoft ASP.NET, so the image I showed you earlier. Then here I will have my sandbox. And then here it's going to read my Docker file, okay? And here basically what I'm doing, I'm simply adding an exe, and then I'm running it. So I will have my image, and then of course, I will have here a sandbox, okay? So I will still be able to change it, to interact with it. So let me show you a bit the difference. Oops. Yes, sorry. Voila. Okay, so I will do that using the command line. So here, if I use Docker images, you can see that I have different images here. I am especially interested in this IIS image. Okay, if I do Docker history, it tells me to see how I built this image. So I'm doing Docker history IIS. So you can see here, basically, this is Windows Server Core. That's the Windows Server Core layer. And here, I am adding another layer that I created by CMD. Okay, that's because I use the command line to install IIS and stuff. But that's not a problem, because if I do docker run -it and then -p, so that's to specify ports. Okay, so I'm going to make it run on 80, the machine, on my machine, so virtual machine, and then 80 on the container side. So left side is outside, and here is inside, so inside the container, if you want. Here, I have to give the name of the image, which is IIS, and I need to give the command, cmd. Okay, so I'm running this. Perfect. And now, if I go here, you can see that normally this is 10.5.121.75. That's fine. So normally here, if I go, I have an IIS. Yes, I have an IIS, which is good. So if I exit from here, just okay, I clicked, sorry. But if I go back here and I press Ctrl F5, I don't have anything yet, because that was an IIS hosted server, okay. Now, I have other images. I know. Basically, I need to go here, and here I have a console app, console demo. Inside this console demo, you can see that I have having a Docker file. Let me just open it with Visual Studio Code. So the first thing you will be noticing is that we have a syntax highlighting for Docker file. We're really happy. And then it's exactly the thing that I showed you before. It's exactly the same, so it does exactly what I described before, okay? So you can find the definition of Microsoft/ASP.NET on GitHub, so it's completely public. You can check it. And so then let me just say Docker build. I will give a name, so it's going to be demo console. And I need to specify where is the Docker file, so it's here. And well, now you can see that it's building. So from Microsoft ASP, so it's built the Microsoft ASP layer and then add my exe, and that's it. Okay. So now if I do Docker images, you can see that I have this demo console that was built 12 seconds ago. So now if I do docker run demo console, it will run my super ASP.NET app, which says hello TechDays. That's the only thing I managed to do. I'm sorry. And so you can see that if I do Docker history on this demo console, here we have much more layers, okay? You can see exactly what happened. So here I run dnvm install the LC1, and here, well, I am adding the file, and then here I'm running the file. So it's really easier to read and to understand how the images are built. I would recommend using Dockerfile if you can. Okay. So, time to enter this section. So, DevOps with containers. So, yeah, no. You're having some kind of tension with developer and IT because they don't have, in the end, the exact same goal. Because developers, they want to build the latest, cooler stuff using the latest stuff. And yeah, on the other side, the IT, they want to ensure that the things are running well. They want to ensure that it's compliant. And, well, sometimes they're not really aligned. The thing about the containers is that it's a separation of concerns between the two, okay? If you think about the container, a developer, so if I go back to my maritime example from before, a developer will care on building the container, okay? So it will actually make the container with everything it needs. It will install the libraries, the dependencies, the packages, and then prepare this nice containers. Then the IT pro will be the guy that will actually manage the ship. So saying, okay, I carried this container, so this version of your app is going with this version. Then, of course, the IT pro will manage everything that he's already managing. So the security, monitoring, logging, and all this thing. That remains the same. The only thing that really changes is you don't have to ask what version of something you need on this machine, because everything is going to be completely bundled inside this container, and this is already quite cool. So we already saw how a developer can build an image, okay? Now, what does he do when he builds this image? Well, he takes the image, he pushes it to the central repository, and then from the central repository, the organization, or if it's the Docker Hub, so the public one, everybody, they can take this image. So for example, think about test, okay? When you instantiate a container, you are basically instantiating a complete new environment. That means that for test, it's perfect. It's a pristine, complete pristine environment. Of course, if you're having other developers that are waiting for special features, they can already get your latest version and have it side by side because they're completely containerized, okay? So they can develop side by side with the containers. And then you can, of course, stage them for integration. Another very interesting aspect with the DevOps process is when you're having an image to the central repository, then the operations team can automate the deployment to a cloud, like Azure, for example, or to everywhere else on your infrastructure or wherever you want. And then they can monitor how these containers are running. And then, so what happens is like the developer read that and they make a new version, okay? So this is this yellow version. And well, sometimes when you have a new version, you're having a bug, okay? So that you have a bug in the cloud, and this is panic, but it's not. Because actually, in the repository, you're having a versioning system. So that means that the operation team can simply roll back to the previous version super, super easily, okay? So I just want to show you that as well. And this is going to be my last demo of the day. Okay. So here, if I do Docker images, you can see that I'm having this NinjaCat demo. I'm having version 1 and version 2. Of course, I'm an evangelist. I always run the latest version. So let me do docker run minus -it minus, so a port, again, because it's, sorry, I did not tell it, it's basically a static website with IIS, and there is pictures and index.html. Okay, so here, this time, I'm going to run it on port 8001 and 80 on the local container, and then NinjaCat and the version 2. Oh, because I forgot to give the command. Okay, I have to give him which command I want to use inside my container, which in that case is cmd. Okay, so now it's starting the new container. So now, normally, if I go here and I go to port 8001, well, I have something, but I don't have the image, because actually my index is completely broken. So let's roll back to next version. Sorry, I'm just trying to make it full screen. Okay. And here, I'm just going to run the version 1. There is a known bug yet, so I cannot use the same port, just to show you the idea. But you can see that I'm having this versioning, and now on, I think I used the 2. Well, I am having these beautiful pictures that Sasha made for us of our Swiss NinjaCat. I saw that we are having others outside with like the welcome in this demo, okay? So I just roll back to the previous version of my website, and that can be done really, really quickly because you're having this automated versioning of images inside the repository. Okay, let me wrap this up. So that's the conclusion. So the containers that we described offer several stuff. So fast iteration, you saw it, it's really quick to start, it's really quick to build. Yeah, you can really, it really helps. You can deploy them rapidly because they're really lightweight. Lightweight, not in the term that you cannot encompass a big application inside them, but you don't have that much overhead. Okay, so they remain quite lightweight. You are having a defined state separation between each layer. That also helps you, and I'm going to talk about it in a few minutes. And the images are always completely immutable, and finally, resource control, which is very important if you think about deploying inside a cluster. So another quite important aspect is this layering system encourages you to build app in smaller parts, okay? So, for example, let's say that you're having an application where you have a website and an API part. Let's say you're having tons of requests on the API side. If your application is built in a monolithic way, well, what you're going to do is probably you're going to scale out, okay? So you are giving multiple versions of this. But when you think about this, that means that the web that was not that much used, you're having copies of it that you don't need. If you think about the containers and the microservices, so the microservice architecture, the idea is that you will do a service that will only do a specific thing of your application, okay? A very specific thing. That means that if you need to scale, you will only scale this specific part. That means that here, in this current problem, what we could have is simply have scaled 2 times the container with your web app, okay? So when you think about this, you might say, okay, that's cool, but that might be a bit complex to manage. So here you would need some cluster management solutions. And then I will say I'm really glad you asked. Because a few days ago, we released the Azure Container Service that you can try. It's public preview. So currently, it's working for Linux because Windows container are not there yet. But what it allows you to do is to build from an ARM template, so Azure Resource Manager, you can build your own cluster, okay? And we're using open technologies to build this, so we are using Mesos, in that case, Apache Mesos clusters. So that means that when you will be running containers inside it, you can also take them back. I mean, everything is open. You can have the exact same technologies on your own infrastructure. And I just want to explain you. So that Swarm, that's something that you can have as well, Mesos or Swarm if you want. And the idea is here we'll have, as often you will have a master, and here they call them agent and not slaves because it's more correct. And the idea is really that you will have a few containers running inside your cluster. And when you want to add a container inside, you will just do exactly what I showed you. So a docker run command on the master. Then the master will decide, OK, this container will run here. And you don't have to manage them. As I still have 3 minutes, I just want to show you Mesos. So yesterday night, I did a container service with Mesos. So here, I'm using Putty because it's on Linux. You can see here, I don't know if you can see, but it's on Azure. If you don't see it, you will have to believe me. And here, let me just connect. Basically, what I'm doing is a tunneling. So the port 80, let me just turn off this. I think I have something running here on port. That should not interfere, but the port 80 on my local machine is going to be tunneled into the port 80 of the master of my cluster, okay? That's what it's going to happen. So let me open this. Yes. Oh, I know what's happening. I just have to. Yeah, sorry, it takes. I forgot to import my private key. So if you wanted to copy it, it's too late. So now I'm going to open it up. Now I'm having this tunnel. Now if I do localhost, and I'm going to Mesos, okay, localhost Mesos, you can see that I will have a view on my cluster. So this is the task that I killed. And here, that's a task that I'm running, okay, currently running. So FAH is folding atom. I don't know if you know it. It's like SETI atom, but for molecule folding. It's a job, basically. Of course, you can see what it produced. So for example, if I go to std out, you can see that it's currently trying to fold molecules and, well, everything that is going. So this cluster, I only have, it's a small one. I only have one master, 2 slaves, or agents. Let me just show you Marathon, which is how I start a new task. So you have this nice interface where you see your cluster. You can say, let's create a new task. And here I want this folding atom, which is done by this air girdler guy. And basically, I can just start it. Yeah, sorry, it's not here. So that's the ID, and I need here. The image is the one folding at home, okay? And here I just create it. And then it will deploy it anywhere in the cluster. If you need to scale out, you just go here. Of course, you can do it without the interface if you want. And, well, you can scale it out. I did it before. Here, sorry, the big blue button. Here you can say I want 100. And then it will scale it for you, okay? So that's a bit the future. So you will be able to scale those containers inside your clusters into the cloud or on your local infrastructure. So here, I just put you like the 2 main links. If you want to learn more about Windows Container, everything that I've showed you, you can do it, okay? It's everything. You can find like a tutorial here. And the container service, you can find more information here, okay? And I will try to reference as well I have video of all my demos, so in case you want to watch them, I will reference them. And yeah, that's it. So thank you. And if you have some questions, I will hang out here around. Yeah, and bye.